Okay, for section 2.6 in college algebra, we're going to be working on graphs of basic functions and graphing techniques. So remember that a function has to pass that vertical line test, and what we want to talk about is when a function is continuous. A function is continuous over an interval if a hand-drawn graph can be drawn over that interval without lifting your pencil from the paper. If a function is not continuous at a point, then we say it has a discontinuity there. So here is a few examples. We're going to give the intervals of continuity for each function. So here, if I start at the left-hand arrow and trace my graph, I can go all the way from one end to the other without picking up my pencil. So this function is continuous all the way from its left end to its right end, which would be negative infinity to positive infinity. But this graph, if I start at the left-hand arrow and trace, I have to pick up my pencil or my pen right here and then put it back down and keep going to the right. So this function would be continuous from negative infinity till I get to 3, and then again from 3 to infinity. So this would be negative infinity to 3, skip over 3 because it's discontinuous there, and go 3 to infinity. This function looks different. I go from negative infinity up to this open circle at 2, so that's going to go negative infinity up to 2 with a parenthesis. But then when I get to 2 up here, it's a closed circle, and it goes to infinity to the right. So I'm going to put a bracket here at that 2 and go to infinity. So this graph here has no discontinuities. This one is discontinuous at x equals 3, and this one is discontinuous at x equals 2, or it has a discontinuity at that value. So let's move on to the basic functions we need to know. We need to know the identity function, y equals x, the squaring function, y equals x squared, cubing function, y equals x cubed, square root function, y equals square root of x, cube root function, y equals cube root of x, and absolute value function, y equals absolute value of x. The identity function is not that big of a deal, but we are just going to still go over it. What we're going to do is start at x equals 0, and that's going to be consistent for all of our basic graphs. So if I start at x equals 0, that's going to be an input of 0 gives me an output of 0. So 0, 0 is going to be my start point. I'll put that graph on there, or that point on there. And then if I move to the left one, I am going to, so if I input -1, I will output -1 as well. So if I move to the left one, then I will also be moving down 1. I need a red pen. Hold tight. Got it. So left 1, down 1. If I input -2, I will output -2. So I will be moving left 2, down 2, left 1, down 1. So from here, if I move left 2, down 2, if I move left 1, down 1, again from that start point. And then I have my rights. If I input 1, I will output 1. If I input 2, I will output 2. So this is going to be up 1, up 2. So from my start point, I move right 1, up 1. And then again from my start point, I move right 2, up 2. And I put those ordered pairs on there. This identity function is actually just a straight line. It's not super interesting, but it's still one that we need to be able to recognize. So I will go ahead and connect that. And I'm going to go to the edges of my graph and put arrows on the ends. The domain of this identity function, if I go left to right, would be -infinity to infinity. The range, if I go bottom to top, would be -infinity to infinity as well. This graph is increasing all the time. If I get on the left, it is going uphill all the way forever. So it's increasing negative infinity to infinity. It's decreasing nowhere. And since I can trace the whole thing without lifting my pencil, it is continuous from negative infinity to infinity. So we're going to do these, like this information for all of our parent functions, or those basic functions that we're learning. So here we have the squaring function. For the squaring function, we are going to start at 0, 0. So I'll put that ordered pair on the graph. If I input positive 1, I'm going to do 1 squared. I'm going to output positive 1. If I input positive 2, 2 squared is 4. So this tells me I'm going to be moving right 1, up 1, right 2, up 4. So from that start point, right 1, up 1, right 2, up 4. And I could actually continue that pattern and go right 3, up 9 as well. So I could keep it going with 3 and 9. And then if I'm moving left 1, if I move to the left 1, I square negative 1, I get out positive 1. So I'm also going up. If I move left 2, I'm going to be outputting a positive 4, so I will also be moving up. So left 1, up 1, again back to the start point, left 2, up 4. And I could as well do negative 3, 9, so I could go left 3 from the start point and up 9. So this graph makes what we have called a parabola. The domain for this function, if I scan left to right, is negative infinity to infinity. The range, if I go bottom to top, starts at 0 and goes to infinity. So bracket 0 to infinity. This graph is increasing, going uphill. So I'm downhill here, and then I start going uphill right here at x equals 0. So it is increasing from 0 to infinity, and it is decreasing negative infinity until I get to 0. So negative infinity up to 0. I can trace the whole thing without lifting my pencil, so it is continuous from negative infinity to infinity. When we graph the squaring function, we're going to start at the vertex 0, 0. That is the vertex. And then we're going to use a pattern to graph the function. So we're going to start at 0, 0, and the pattern that we're going to use to get the rest of the points is we are going to go right 1, up 1, right 2, up 4. And then we're also going to be going left 1, up 1, left 2, up 4. Now if you want to extend that pattern to 3 and 9, left 3, up 9, then you would get the shape of that U. Maybe I should have written that differently. Like if we go 0, 0, we go right 1, up 1, right 2, up 4. I don't know the right way to show you this so that you get the picture of what's going on, but this graph always has that same pattern. Start at 0, 0, go over 1, up 1, over 2, up 4, over 3, up 9. Anyway, we'll see some more. Cubing function. The start point for the cubing function is also 0, 0. So we're going to put that on our graph. This time, if I do an input of positive 1, 1 cubed is 1. I will do an output of 1, which is an up. If I do an input of positive 2, 2 cubed is 8, so 2, 8, which is also up. So starting at the start point, over 1, up 1, going back to the start point, go right 2, up 8. And then if I move to the left 1, negative 1 cubed is negative 1, so I will be moving down 1. If I go left 2, negative 2 cubed is negative 8, so I will be going down 8. So starting from the start point, left 1, down 1, back to the start point, left 2, down 8. And then this shape looks like a parabola on this side, and then it looks like it got twisted in the middle and made an upside down parabola on this side. Get those arrows on there. The domain of this function is negative infinity to infinity. The range is the same. This graph, if I get on the left end, I am always going uphill, so it's increasing from negative infinity to infinity, and it is not going downhill anywhere, so it's decreasing nowhere. And it is continuous from end to end, so negative infinity to infinity. The secret to graphing the cubic function is we are going to start at 0, 0, and then the pattern that we're going to follow, from the start point, we're going to go to the right 1, up 1, to the right 2, up 8. And we're going to go back to the start point, go left 1, down 1, left 2, down 8. Our next one is square root. So when we do the square root function, we are going to start at 0, 0, because the square root of 0 is 0. So we start at 0, 0. We can't take the square root of a negative number and get a real answer, so we aren't going to use any negative inputs. We are going to use an input of 1. The square root of 1 is 1, so I will go to the right 1, up 1. So right 1, up 1, put a dot. The next number I'd like to take the square root of is 4, because it comes out nicely. Square root of 4 is 2. So in this pattern, I start from my start point, go right 4, up 2. 1, 2, 3, 4, up 2. The next number I would use is 9, because the square root of that is 3. So if I go back to the start, move right 9, up 3. And then I could go again with 16, go right 16, I would go up 4. And then when I connect these dots, it makes kind of like this eyebrow shape. The domain of this graph starts at x equals 0 and goes to infinity. So 0 to infinity. The range, bottom to top, the first y value is 0 and it goes forever. So the range is also 0 to infinity. This graph is increasing, starting at 0 and going to infinity. So it's increasing 0 to infinity. It's not decreasing anywhere. And it is continuous, starting at 0, so I'm going to use a closed bracket, and going to infinity. The secret to graphing this one is to start at 0, 0, and then the pattern is to go right 1, up 1, and then right 4, up 2, right 9, up 3. And we could keep that pattern going to 16 and 4, 25 and 5, 36 and 6. But that's our pattern. Cube root function. I can take the cube root of negative numbers, so I have some negatives in here. I'm still starting at 0, 0, right there. And then if I take the cube root of 1, I get 1. If I take the cube root of 8, I get 2. So I will be moving from the start point, right 1, up 1 to get my first point, right 8, up 2 to get my next point. And then since I can take the cube root of negative numbers, cube root of negative 1 is negative 1, cube root of negative 8 is negative 2, I will be moving left and down, left 1, down 1 from the start point, and then left 8, down 2 for the next point. So this graph kind of looks like a square root graph here, and then like an upside down and backward square root graph here. The domain for this function is negative infinity to infinity. The range is the same. It is increasing or going uphill over its entire domain. So negative infinity to infinity. It is decreasing nowhere, and it is continuous everywhere. The secret to graphing this graph is to start at 0, 0, and then use the pattern to go right 1, up 1, right 8 up 2. We could go another one into 27 and 3, but that's kind of off the graph. And then we go back to the start. We go left 1, down 1, left 8, down 2 to make that shape. Our last type of graph we need to know is absolute value. Again, we start at 0, 0. And then if I move to the right 1, or the absolute value of 1, the output is 1, so that will be right 1, up 1. Put absolute value of 2, I get 2, so I'm going to go right 2, up 2. So right 1, up 1, go back to start, right 2, up 2. I could keep that going and go 3 and 3, 4 and 4, 5 and 5. I could go forever. But then if I put the absolute value of -1, absolute value of -1 is 1. So I will go back to that starting point, left 1, up 1. Absolute value of -2 is also +2. So I will be going left 2, up 2 from my start point. I could go back to the start point, left 3, up 3, and I could keep that pattern going forever as well. So this graph looks like a V. I should use a straight edge. Like that. And like that. The domain for this graph is -infinity to infinity. The range is from 0 to infinity. It is increasing or going uphill, starting at x equals 0 and continuing to infinity. So increasing 0 to infinity. It is going downhill, -infinity to 0. And it is continuous over its entire domain. The key to graphing this one is to start at the vertex, which is 0, 0, and then the pattern is to go right 1, up 1, right 2, up 2, and then go left 1, up 1, left 2, up 2. There are lots of other functions, but these are the ones we're going to focus on in this chapter. So let's just kind of refresh and get everything in one spot here. The squaring function, f of x equals x squared. We start at 0, 0. The pattern is to go right 1, up 1, right 2, up 4, right 3, up 9, and then we go left 1, up 1, left 2, up 4, left 3, up 9. That graph looks like this when we graph it, just as a visual reminder. The cubing function, we start at 0, 0. The pattern is to go right 1, up 1, right 2, up 8, left 1, down 1, left 2, down 8. That one looks like this, with our starting point right there in the middle. Square root function. We start at 0, 0. The pattern is to go right 1, up 1, right 4, up 2, right 9, up 3. This one looks like the eyebrow shape. Cube root function starts at 0, 0. And then the pattern is to go right 1, up 1, right 8, up 2, left 1, down 1, left 8, down 2. That one looks like the square root, and then upside down backwards square root. Then we have absolute value, which we start at 0, 0, and then we go over 1, up 1, right 2, up 2, left 1, down 1, left 2, down 2. And that one looks like a V shape. So we need to know how to graph all of these basic functions so that we can then start to learn transformations, which is going to be coming up in the next section.